Hot surfaces and liquids don't mix. Drop water on a really hot surface, and instead of evaporating, the droplets start to skitter around. This is called the Leidenfrost Effect, and it can be a problem if you're trying to use water to cool down systems prone to overheating. That's why Zhuangkai Wang and his colleagues in Hong Kong have found a clever way to get rid of the Leidenfrost effect and create a surface that water will evaporate from instead of bouncing off.
The Leidenfrost effect is a classical physical phenomenon first observed in 1756 by a doctor named Leidenfrost.
This physical phenomenon isn't just confined to the lab.
Actually, this kind of phenomenon is very ordinary. It's anywhere.
For example, in the kitchen, bouncing water droplets let cooks know that their pan is up to temperature. In this case, that temperature, known as the Leidenfrost point, is around 200 degrees Celsius. Below this point, the water just starts to boil and evaporate away.
If the water droplet will evaporate very quickly, that means that the surface temperature is not that high. I think it's below 200 degrees.
But above this point, something strange happens. When a water droplet hits the pan, the bottom of it evaporates instantly, turning into vapour. This water vapour forms a cushion under the droplet that it can slide around on. It also acts as a kind of insulating barrier because the rest of the droplet isn't in direct contact with the pan and so doesn't evaporate as quickly. Bouncing water droplets and a lack of efficient evaporation can be a problem. Liquid-based cooling systems in things like manufacturing and nuclear power plants depend on evaporation to get rid of excess heat. So scientists have been looking for ways to get rid of this insulating layer.
So this is a challenge occurred over the past 200 years, how to break the Leidenfrost effect.
And various solutions have been put forward. For example, a grooved, textured surface helps stop the vapour layer from forming and keeps the liquid in contact with the hot material. But this only works up to a point.
So far, the highest Leidenfrost point is around 500 degrees.
No one has been able to stop the Leidenfrost effect happening at extremely high temperatures. Until now. Zhuangkai and his team have developed what they call a structured thermal armour. The new design includes a special membrane embedded in the channels which wicks the water down into the grooves.
The membrane can suck the water very efficiently. So once the water contacts the membrane, the water is absorbed and then spread on the surface and then become evaporated.
The combination of the texture and the absorbent membrane stops the droplets from bouncing off and helps the liquid evaporate so it can efficiently cool down the hot surface. So how hot can this new technique go?
Actually, there's no limit. Because on our armor, we couldn't see the Leidenfrost effect.
During testing, their structured thermal armour reached 1,200 degrees Celsius without any bouncing droplets. But at that point, the steel it was made from started to melt. Zhuangkai thinks with different materials it could get even hotter. And the flexible armour could be used in a range of cooling applications.
For example, in nuclear power plant, right, we want to remove the heat at high temperature. And also in turbine, in engine, right, or in aircraft, the current approach is not that efficient. So think about one day, we can replace the current material with our armor. And then you can just spray the water on the armor. And suddenly, the temperature will drop